Welcome to Brain Vision.
Now for this question, we have an object experiencing a force, and we are given the expression of the force F equals to alpha xy in the I hat direction, which is along the x-axis. Alright, and what we want to do is first we want to sketch what is the movement of our object. So we know it starts off at the origin 0. It moves along the y-axis to reach the first point, where it is at 1.5 meters. So this is the first movement. It then moves along the same y value all the way to x equals to 1.5. So this is the second one. Finally, it moves down all the way to y equals to 0. And finally, it moves back to the origin. What we want to do is to calculate the work done for each part of this movement. So for the first part, total work done, we take F dot dl Now we know that dl must be in the same direction as our force, which is I. But in this case, our x did not change at all. Right, our x is at 0. So basically our force is 0. And therefore the total work done must be 0. For the second part, we are moving from x equals to 0 all the way to x equals to 1.5. In this case, our y is kept constant at 1.5, so we can pull that out. So this is alpha times 1.5 integrating x dx from 0 to 1.5. Doing this integration, we would get Therefore, our answer is 3.38 joules DC work done. Next, for the third part, once again, our x is a constant. And so, basically our x doesn't change. And since the force is only acting in the x-axis, and we are moving in a perpendicular motion to the direction of the force, then there shouldn't be any work done. Work done is 0. Finally, for the fourth part, we are moving in the negative direction. We are moving from x equals to 1.5 all the way to 0. In this case, our y is at 0. And because our force includes y in this expression, if y is 0, our force is 0. So basically, the work done is 0. And therefore, the total work done moving along the entire path, summing up all of these values together, we get 3.38 joules which is non-zero, and therefore we can conclude that the force is not conservative. Because if it were conservative, it will only depend on the initial and starting points, and if you have to have a closed loop, it means the initial and ending points are the same, and we should have a total work done of 0 for a conservative force. But that is not the case for our particular force that we're interested in, and therefore this must be a non-conservative force.